here's the thing. Every EC2 instance has a small sidecar next to it. It's really like a small container that's living next to it. Let me just visualize it as a small EC2 instance. And this is the metadata service.
Hello.
Hey, Will, how's it going?
I'm not bad, not bad. How are you?
Yeah, I was just complaining about allergies. A couple of more minutes just to make sure that. Hey, man, it's good to see you. Let's do this. So, Atul, would you like to give us just a quick introduction about the scenario, explain a little bit, the whole concepts for this interview question, and let's start dissecting it and see how we can rewrite it, improve it, and all that good stuff.
Actually, it was recently we means I went through a couple of interviews, and this was one of the interview question. And the scenario is we have multiple loads, and all load is facing internet directly in the public subnet. And the question is to make it highly available. We don't have auto scaling, make it secure, and also cost optimization. So these are the primary concerns currently. Means they asked for this, and then this is how the chat started. And I proposed one or two solutions. Means we could add auto scaling, and we could move the public subnet assets into private subnets, such. So I thought better to discuss this openly with everyone so that we can open up for the system-based system interviews, system design interviews. Yeah.
Beautiful. Okay, so one region, one AZ, one VPC, and
Yeah.
what's the Okay, so here I see there's multiple public subnets, but what's the entry point?
Yeah, means through internet gateway, Elastic IP. They are open to via Elastic IP directly. The public servers are able to. We are able to.
So here you have like an API gateway, a load balancer, an Elastic
No load
gateway.
balance. I mean, it was directly exposed. No, so no load balance.
Okay, interesting. Yeah. So that's the first thing that comes to mind about
That's why
security.
no auto scaling was means I could suggest the auto scaling because nothing was it was directly facing, and we could see the only one instance that was the.
I see. And every instance exposes its own public IP. So the public IP of the instance is public, and that's how we reach the instance directly. The second thing I see here is the databases in public subnet. Those are just low-hanging fruits. And guys, feel free to chime in also if you see anything here. Okay, you know what? Let's start rewriting this. Let's start redesigning this and start with the AWS cloud. So this would be our V2, and then in the AWS cloud. So let's just put an EC2 instance here. And this, you said, a Windows EC2 instance. And then there are Linux EC2 instance with 3 apps. Is there a reason why 3 apps within one instance? And the second question is, what does it mean orchestrator app here?
Actually, that means all the whatever traffic is coming, it will be handled by that particular one application.
I see.
And only one or two applications from another instances will be exposed to directly to the internet. But majority of work will be done by the one main application. That's what.
I see. Yeah. So I would just call it a router or fan out. Usually, that's like the fan out pattern where you have. Usually, I see it more with Lambda functions where you have one function that does the routing. All it does is routing. So it would be like one Lambda function that calls the other functions. But let's just, okay, you know what? Let's keep the nomenclature. So orchestrator. And then you have one EC2 Windows machine, and then there's a Linux machine. So there's Windows VM, and then you have a Linux VM. And there's 3 apps within the Linux VM. Is there any specific reason for that? Is there any specific reason we can't have every app in its own instance? That way we can, scale them differently, give them resources, secure them differently.
No idea.
Okay. So let's say Linux EC2. So let's split. So let's have our Linux VM1, Linux VM2, or Linux VM3, or Linux VM app1, and this would be up2, and then we would have an up3. Let's say we have 3 apps actually in this layer. All right. Boom, 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 boom. This like this. So let's go back here. And then because this EC2 instance is only accessible through the orchestrator, right? It doesn't have to be in a public subnet. It can definitely be in a private subnet. So it doesn't have to be in a public subnet, but we'll get to that. And also the orchestrator has access to all these databases. So we have multiple instances of RDS. Let's say we have MySQL, and I saw MariaDB and MS SQL. Now let's just put a generic database here. All right, and we'll have multiple instances of these as well. What else? Then you have multiple S3 buckets. Now, again, I don't think you need multiple S3 buckets unless there is a specific reason for it. Usually one S3 bucket can be leveraged, and you can use folders within the S3 bucket to separate or segregate for all the to follow up the requirements. So unless there is a really specific reason, because S3, there's no limitation really to how it can grow. And if it's like the size doesn't affect the time that the queries would take, right? If you have a million object there and you try to fetch something, it's going to take the same time as if you have 3 objects there and you're trying to fetch something. So usually best practice is to use one bucket and then use multiple folders within it. And it makes it also simple to grow it and evolve it, right, with time. If you are worried with, for example, pricing, and you want to give this S3 bucket, you want to make it you want to give it standard access or storage class, and this one you want to give it something else, you can create rules to manage the files within your S3 buckets, even if like based on folders or even based on tags of the files or based on names of the files. I keep saying files. In S3, we like to call them objects, but it's pretty much the same thing. So here I'm wondering whether there's a specific reason to have 3 S3 buckets. Like in an interview, I think it's always great to challenge, because if you pass in an interview for a solutions architect and they give you something, a question like this, they're not expecting you to start working on a solution right away. They're always expecting you to challenge it and to ask for more information, because on purpose, they put stuff that are out of place. So on purpose, they want to see how you think about, for example, multiple S3 buckets versus one. And so they want you to keep asking questions about these kind of things. And that's pretty much what we're doing also in this exercise. For my design, I would go with one S3 bucket. Of course, guys, everyone here, questions. Oh, there's chat. More buckets, more fun. Oh yeah, lifecycle policy. Sorry, I was not reading the chat. Now I will be reading the chats because I have multiple screens. Yeah, more buckets, more fun for sure. But not fun for whoever manages the infrastructure. So let's say we're going to create one S3 bucket. So we're going to use one S3 bucket rather than multiple ones. And here we have multiple Lambda functions. So Lambda functions are the opposite. We want to use as many as we can. We want to think about the function as, the Swiss Army knife of AWS cloud, and you want to build your function to make them super simple, super small, and do one simple thing. So for Lambda functions, we will use 2 of them. We will keep 2 of them. All right. And then you have a DynamoDB table. Do we know what kind of data is stored in the DynamoDB table?
No.
Okay. So
this information, Lambda was pulling the images from S3 and it was performing some operations using AWS recognition, and for quick access, it was stored in DynamoDB for later use. It's whatever the results were there.
Yeah, Lambda as pure as possible. Yes, definitely. Let's say this application would put a file in the S3 bucket, then this S3 bucket would trigger the Lambda function that will take that image, run some operations with AWS recognition, and then write the response into the DynamoDB table. So probably this is gonna be extracting, for example, objects from the image and then storing those metadata in the DynamoDB table. So let's say put a city. Yeah, whatever. Let's choose this one. So let's say we are using this picture here. Let's store it. So let's say the application drops this picture in H3, Lambda will take it, use recognition. Recognition will find there's a boat, there's a river, there are skyscrapers, there's a sky, there's color green, there are trees. And I'm thinking then the Lambda function gets that back and then stores it in DynamoDB table. So the application now knows the components of this specific image and they're stored. And I'm thinking that every image would have one document in DynamoDB table. The ID would be the name of the image or the ID that the application provides, and then all the other metadata would be here. I'm just trying to assume that's what I would do with this. That's how I would build this if I had to. So let's add recognition here. Is it Amazon or AWS? It's Amazon recognition. Yeah. Let's add Amazon here, and then let's add our DynamoDB here. All right, let's see how we can work on this layer by layer, step by step. So first of all, I wouldn't want us to have an EC2 and to put an EC2 instance as the entry point. I would either put an API gateway or I would put a load balancer. Now for load balancers, there are 3 of them, right? Amazon load balancer. There's 3. There's the application load balancer, there's the gateway load balancer, there's the network load balancer. The gateway usually is, the application load balancer is layer 7 of the OSI model. It's on the application side. So every time you need to route your application through URL, for example, if the URL starts with /users, I want to do this. So you choose, so you're at the application level, so you choose layer 7, so you choose application load balancer. The gateway load balancer is level 4, is the transport. So if you want to use through, so if you want to route or balance or distribute the load and your application uses TCP, UDP, and we see these if you want to use, for example, a VPN, or if you are building a live chat application or a live streaming where you really want to use that protocol directly. So we go to level 7. And network load balancer, that's on really if you want to use IPs, that's level 3 on the OSI level. So that's pretty much how to look at the different load balancers. I think here, like if I was in the interview, I'd be asking the interviewer what kind of traffic are we getting? And from the pictures here, I see it's going to be coming from like a mobile application, right? So that's level 7, I'm assuming, for private containers. Yeah, it's tough. We all gotta start somewhere. It's fine, but yeah, this is the way I learned to differentiate between them. Like there are multiple features and stuff, but I just use the OSI layer, and it makes it simple for me. So mobile applications, I'm assuming it's gonna be layer 7, and OTT. What is OTT here?
Means multimedia delivery platforms.
Oh, so now we're talking about media stuff. Like streaming, like streaming media files.
Yeah.
Okay.
Yeah.
So if we're streaming, yeah. So now we need to ask them more. What kind of protocols are we using to stream? You know, Apple has its own thing. There's HEVC. There's the whole thing that Android uses. And here I'm thinking either we use something like a gateway load balancer, or we use Amazon media services. What I'm looking for, services here, interactive, elemental. Yes, the elemental what I was looking for. So there's Media Live, Media Tailor, Media Connect. That's what I'm looking for. So if we're talking about streaming coming, for example, either from a live source or not even from a live source, just a video that is being streamed byte by byte, you want to use something like AWS Elemental Media Connect because it allows you to connect to that source and then convert even that source as it come in live and then process it and do whatever you want to do with it. Like maybe that's what they were expecting you to ask for. They specifically put these different type of applications so they can see, whether the interviewee is able to separate and build different architectures for different applications. Now, I remember I'm not going to go there in details in the media suite because I have a specific video about building, and it was a live actually, about building something with Elemental. It was a live video about building a VOD platform, a video on demand platform with this one. Okay. Yeah, we did a stream at some point, and we built this whole pipeline about like the producer would put a video in a raw S3 bucket and then using all the media Elementor suites to process the videos and sense events and prevent. So I'm not going to go through that path for this one. I'm just let me share the link in case you want to watch it later. Let's go back. I want to have an application load balancer here. Load balancer. All right. I want to put my application load balancer here. And I want to get rid of the orchestrator. Unless the orchestrator is doing more than just doing a fan out, I really want to get rid of the orchestrator because I don't want the orchestrator to do the routing if application load balancer can do the routing. So I want to get rid of the orchestrator here. And I want to use application load balancer to say all calls that starts with API v1, I'm going to route them to the Windows VM. All the calls that starts with, and these are rules that you can build in the application load balancer. All the calls that starts with, you'll have to build also application. This is application 1. I want them to go to here. For all the calls that starts with this, I want to put 2 would go to application 2, and all the calls that starts with 3, I want to push them to application 3. Okay. Now in front of the application load balancer, I can have my ALB public facing for sure. There's no problem at all. It is built for that. But what I can do also here is I can add. It depends on the application and stuff like that. But I can start adding CDN like CloudFront. I will add also something like WAF. Let's add CloudFront. Amazon CloudFront here. So again, I can hide the IP of my application load balancer. No one will have ever access. No one will know the IP of my machines, and no one will know the IP of my application load balancer. What people would know, what the front-end application would know, it would be only the CloudFront URL, which is already public. I don't care about that, right? But to protect myself again from DDoS attacks and all that kind of thing, I can use WAF. Now, WAF is what AWS calls Amazon Web Application Firewall. And it's something that you can put in front of CloudFront or in front of the application load balancer of an Amazon API gateway or AppSync. AppSync is to build your GraphQL applications, and you put WAF in front of it. And if we see the features that WAF provides, for example, based on rules, based on IPs, you can control the bots, you can protect yourself against DDoS attacks. So I would definitely put WAF here, especially that you are having multiple third-party here applications, right? There's mobile, there's third-party, maybe you have a POS system, maybe there's a smartwatch in the mix. And I want to protect myself from all the attack vectors and all the threat models that are coming from these actors. And I want to let AWS handle this for me. So I would put a WAF here. And then behind the WAF, I would put a CloudFront. So this would be the only thing that is publicly available and known by my actors here, by my front-end subscribers, consumers, whatever. I would put an application load balancer. This is private here. no one outside of my VPC, of my AWS cloud account knows the IP of the application load balancer. And now for these, this is something that you mentioned also, Atul, is every one of these applications, I would put it in an auto-scaling group. I would want to ask them whether they are open to use containers for these applications, or whether they're open to use something like serverless Lambda functions, or maybe they're open to use spot instances. So I would be asking them more questions about the access patterns. What do these applications do? Are these, maybe this Windows, maybe this app2 can run some batch, does some batch processing?
I asked this probing question, then they said that we don't want, either we should go for little change or no code change in the current, whatever scenario is. Please suggest
I see.
according to this. Yeah.
I see. Okay.
Yeah.
So when we have a problem and we try to solve it, there are multiple angles we can approach it. We can either solve it from a code perspective. If we can't solve it from a code perspective, maybe let's see if we can solve it from an infrastructure perspective. So let's say our hands are tied, we can't touch the code. So let's see if we can make it better by changing the infrastructure instead. We have a comment, Fargate or EC2 auto-scaling container. Yeah, that's what I was thinking. I was thinking about Fargate. Containers scale, first of all, faster than VM scale. And second of all, it's cheaper. And third of all, you take your container that your developers worked on locally and you just deploy it there. It's the same, it's a container. And there are also other optimizations that we can do to bring the cost even down. But if we can't, we have to stick with EC2 instances, then let's start using our auto-scaling containers here. Yeah. Dockerfile is way easier. And also there are some, I've been reading recently about the IMDS 2 of EC2. So there's been this vulnerability. So if you guys are using EC2 instances at your work, make sure that you're using the version 2 of the metadata service. It's IMDS v2, because there has been, okay, so here's the thing. Every EC2 instance has a small sidecar next to it. It's really like a small container that's living next to it. And that container is, let me just visualize it as a small EC2 instance. And this is the metadata service. And usually for a long time, we had IMDS v1. Let's say this application here needs to access this DynamoDB table. Well, the roles, the secrets, the permissions, everything, it lives not in the machine itself. They are stored in IMDS. So this VM will check with the metadata service, gets the information, then either forwards or stops or whatever. And every EC2 instance has this small thing like here, but you can contact it using an API call. I think it's 254.196. It's a static IP. It's a static IP that you can access. 169.254. They all start with 169.254, all these sidecars. And so there's been this vulnerability where people were able to query from outside, query this in some specific use cases, using some specific behavior, whatever, but it has been like, there's been a vulnerability and they fixed it. So just make sure you are using V2, fixed it in V2. That's beside the point. Let's go back. Let's start using our auto-scaling group. Instance contents, beanstalk, auto-scaling. That's what I was looking for. Anshul says if we were to add the URL to Route 53, then would be mobile-based URL, browser-based URLs, put in origins on CloudFront. Yeah, definitely. We can put a Route 53, because sometimes what you see is that people would use another DNS provider, right? And so the DNS provider would be, let's just use Route 53 since we are in AWS, Amazon Route 53. So it would be like here. It would look like something like this. Would be mobile-based URL. So I'm trying to understand. So you said then would be mobile-based URL and browser-based URL put in origins on CloudFront. Okay, I get it. So you're saying that we can have different URLs and every one of these URLs. So within our DNS zone.
Yes, correct. Absolutely.
Okay, got it. Sorry. Yeah, you're right. So it would be something like this. This is web, this is mobile, and let's remove this, for example. and every one of them would have its own CloudFront origin. Yeah, for sure. But at the end of the, why we want to do that is if we had multiple behaviors, like we had multiple cache behaviors. So that's a good point. Let's put this here. Let's put this here. I want to keep WAF there. So let's say this has, web, a different cache behavior. If something coming from the web, you want to cache it for 3 days. But if it's coming from the mobile, you want to cache it for 3 hours. So you can have something like this, and then you can have them. Yeah, you will have to see, because maybe you don't have to. Maybe it's going to just cost more. Maybe it's better to use just one. So you're going to have to look at all the business rules that you have. But yeah, we can definitely do something like that. But keep in mind that these are the same distribution, CloudFront distribution. You can definitely create multiple ones, but I suggest you keep the same CloudFront distribution. You just use multiple cache behaviors. CloudFront distribution here, but you'd be using multiple cache behaviors and configurations and whatever you need. So for the Windows VM, so yeah, let's say this is our Windows VM auto scaling group. And then we'll have the same one for our Linux VM app one. Rather than VM, we'll just call it Linux application one auto scaling group. Let's call this would be app 2. And then we would have app 3. And inside every one of these, then there is your EC2 instance, multiple EC2 instances that scale. And so now the next question is, how are we going to scale up and down? How are we going to decide to scale? And there are multiple ways we can approach this. Up. Just copy these like that. Just copy these like that. Do we know if the calls are synchronous or asynchronous? Or maybe it's different per application?
Oh, I'm not clear on that. Means.
Okay. Because what I'm thinking is, I'm going to do some cleaning here. Because we can use the number of requests coming through the API gateway as a scaling policy. We can say, if we have more than this number of requests coming for 5 minutes, then I want to scale up. If not, I want to scale down. We can use the CPU of these EC2 instances. We can say, if the CPU gets to 70% usage for more than 10 minutes, I want to scale up, or I want to scale down, right? So that's the first thing when we think about auto-scaling groups. And the second thing is, what is my desired capacity? What is the minimum capacity and what's the maximum capacity? And that would help if, when you have more information about the type of application, about the budget, if there's any, about also the type of instance that you haven't talked about that, but the type of the application would help you choose the right instance, whether it's memory optimized, storage optimized, IO optimized, and all that kind of stuff. But yeah, so that would be it. Yeah, you know what? Maybe I put this here. Sorry, I'm adamant about building diagrams that look beautiful. And then do some cleaning here. I could do something like this. All right, so we can get back. Our request is coming. We get some protection here. RAM, yeah, 80% CPU RAM for 5 minutes in the past. Yeah, that's usually I would tend not to go over 70% or even 60% to be safe, because it takes at least a couple of minutes for your auto-scaling group to kick in. I don't know, maybe it depends on the instance, right? Some instances are faster than others. Let's say 1 minute. So if you wait sometimes until you reach 80%, by the time you scaled and your new instances are up, maybe you're already saturated at 100%. So it depends on the application, whether it's latency critical, latency sensitive, or whether it's also synchronous, asynchronous, because if it's asynchronous, what we can do here is we can put a queue, right? And then we could use a queue, and we could use the number of events in the queue as an indication to scale up or scale down. So a queue will always host all these events and keep them coming in and chew there. And so if we go more, if the queue has more than, I don't know, 1,000 events in the past 30 seconds, then you know that you need to queue up. So we can use multiple ways to scale up and scale down. But yeah, usually I like to be safe here. So maybe the Windows application actually needs, its desired capacity is only one. You just need to run one instance all the time, and you only need to scale up if there's load. So these are questions you want to ask also. Maybe app2 needs 2 instances to be running all the time. Let's leave the others at 3 instances running all the time. Now, also, it's why I said it depends on the type of the application, because this is the cloud and you are paying per usage, and you want to pay as little as possible. You always want to be cost conscious. So EC2 instance types, there's a website that I love. Oh, this one, Vantage. When I need to choose which EC2 instance I want to use, I go to this website and I start comparing them. So let's say I need 6 gigabytes, let's do 8 gigabytes of memory, and I need an instance storage, EBS, whatever, and I need, I don't know, 8 vCPUs. So it gives me, the multiple instances, and then I can just click, and then I can compare selected, and I see the price and everything. And so the price here is important. Usually, we start by doing on-demand pricing, meaning we pay per hour. So this instance, A1 double extra large, would cost me 20 cents per hour if I pay it on demand. But if I reserve it, it's going to cost me roughly half that. So if I pay for up to 3 years and reserve those instances, it's going to cost me half. Why this is important? Because this is the public pricing. But once you reach a level, AWS will offer you private pricing, right? So you can start negotiating with them, and they could even invest and offer you a 30%, up to 30% discounts on this price and stuff like that. So you want to talk about this with your, CFO or whoever managing budget. But there's also this category of spot instances. I think options for ECS optimizing is also available if you want to go that path. Okay, let me open it. ECS optimized, pre-configured with the requirement to run your container workload on. Oh yeah, definitely. So yeah, so these are instances that are completely optimized for ECS. Yeah, you don't need, usually for 90% of workloads, you don't need to reinvent the wheel. You just have to look a little bit to search, and you're gonna find your solution in AWS, stuff like that, and it makes your life a lot easier. Amazon Linux 2 is Amazon's version of Linux. It's their own distribution. It's based on Fedora, if I remember correctly. And see, this is super. I'm going to go on a small tangent here, but this is super interesting for me. You see, there are distributions and images that are optimized for the type of workload they want to do, whether it's machine learning inference or whether it's GPU optimized calculations. And AWS is pushing it even further, and they're building chips, hardware that is optimized for workloads like Amazon Graviton V2, for example. Oh, there's 3 now? Wait, there's 3? Oh, nice. 25. Okay, so there are chips that are optimized for different types of workloads. So Graviton is ARM if you don't want to use Intel-based processes, and it's usually way cheaper and way faster. I also encourage you to deploy your Lambda functions as ARM rather than the Intel default. Sometimes you'll reach benefits in price and cost. But I'm thinking that, oh yeah, there's compute optimized, memory storage optimized. They build in, Amazon is like Apple does its own silicons. Amazon builds their own silicons. And I'm thinking in the future, we will see silicons to replace services. Like, why use Amazon Aurora as a software, as a service, if you can get an instance, an EC2 instance that has Aurora hard-coded in the hardware as gates and hardware stuff in the chip. Imagine, like, it would be mind-boggling if we can get the software running as a hardware. But I think we'll get there, because that's the ultimate. You don't need to compile the language. You don't need to load stuff. You need to load stuff in memory, but you're going directly to the machine, and it's super optimized. Okay. Now we'll look at this. We have, yes, go ahead.
See when you're looking at the size of instances within the auto-scaling group, how do you kind of determine what size the instances would be? Because obviously the smaller they are, the more finely grained your scaling can be, but you then don't want to have like 200 T2 nanos or whatever. So how do you kind of determine the size your instances should be inside the ASG?
Yes, great question. The only way to do that, the only way I know how to do that, is to test it. So there's two parts. The first part is you are talking with your product people and you're asking them, hey, how many users are we expecting on this, right? If it's a new feature, am I expecting, let's say it's an e-commerce business and you're expecting 1 million users a day, but during sales seasons, it's going to go ×3 or ×4. So you have an idea already, because you say, okay, 1 million requests a day, it translates to this many requests a second. This request, usually it takes, just saying numbers, 200 milliseconds to answer, because and then it needs this type of memory, it needs this type. So like you have an idea, and then you choose the right instance based on that, based on your application. The second thing is, once you choose that, you try to be like, you choose a fair assumption, you make a fair assumption, you deploy it, and you monitor. And then you start dialing it down, right? Let's say you use 10 instances at the beginning, but then you notice that during the first day, only 3 of them have been used. So you dial it down until you find that sweet spot. It's gonna depend. That's why in the cloud, we talk a lot about rightsizing. Let's say AWS rightsizing recommendations. And AWS will offer you some recommendations about how to right size, but there are also some third-party applications. And this one I'm very familiar with, called KubeCost. If you are running Kubernetes workloads, for example, KubeCost will be looking at your cost and utilization of your compute, memory, storage, and then it will suggest you, it will say, hey, you're better to use this specific instance and this specific number of instances. There are other ones that you can deploy directly on AWS and that work with your EC2 instances. But the right answer is your right size. Like, you start with an assumption and then you keep dialing up or down until you find that right sweet spot.
Gotcha, that makes a lot of sense. Thank you.
Yeah. So anything else, guys? Anything else I missed here before we move to our next layer, which is databases? We don't know much about the applications, but I'm assuming that these applications will require caching, for example, because you don't want them to go directly to the database. You never want to talk directly to the database. I mean, okay, let me take a step back. There are multiple schools of thought. I tend to agree with the one that says you never want to read from the database, because database is disk, and you want to avoid reading from disk as much as you can. Always check budget, how to avoid buying another yacht to Bezos. I mean, I saw this interview where Bezos is saying the recession is coming, and if you want to buy a TV, maybe you have to wait a little bit. And I'm like, why does even Bezos care about buying a TV? Like, it seems just disproportionate for me. So let's say, okay, in the initial design, there's multiple databases. Okay, question, do all these applications need to have access to all the databases, or every application has its own database? Do we have the answer to that?
Yeah, means the main one application orchestrator has access to all, and other application have their own databases. That's what
Okay.
they explain. Yeah.
Okay, yeah. So this orchestrator seems to me like hell gates. Like it has access to everything. It is public. It has access like to the history, to the databases. It routes all the traffic. It handles all the traffic. Like it does so many things I wouldn't want it to do. Exactly. Yeah, I was going there. I was going to the RDS proxy. What I was thinking also is whether we can use Aurora for this or only RDS. And the differences are huge, but you only want to use Aurora if you need to use Aurora. I have a, let me see if I can find it. Oh, we shared, I think I shared it in the community. I think I shared it in the community, the decision tree.
Yep, you shared in the community.
Yeah, exactly. So let's open it here and see what we can do. Decision tree DB. Oh, okay.
Yeah, it's there. How to choose the right DB engine.
Okay,
It's there
there
at
you
the
go.
center.
Yeah. Yeah, so whenever I have to choose between Aurora or RDS, I try to think about that. So do you need cross-region replication? Is it a must-have or not?
The region they mentioned regarding it should be it should meet compliance like GDPR and HIPAA, means we can't move out of region. It means. So,
Oh, we can't. Okay.
yeah.
Okay, so let's say cross-region replication is not a must-have. So then we go to step number 2. Do you need manual snapshots in the database? So let's say yes, because why not? We need backups always. You need to think that backups need to be secured, and these manual snapshots, they go to Amazon S3. So it's an S3 bucket. So you need to either encrypt that bucket, remove access, like close access to it, and all that good stuff. And then the next question is which database you want to use. Postgres, MySQL, MariaDB. That's because, let's see, maybe it's better to open it in Xmind because I have more. I need to download it because here there's notes. Because, for example, Aurora, there's no Aurora for Oracle. There's no Aurora for SQL Server. It's only for MySQL, MariaDB, and Postgres. And here, whether it's a web or mobile application, I'm recommending RDS, e-commerce RDS. But for SaaS application, I'm recommending Aurora for multiple reasons. It's because Aurora is, according to Amazon, 5 times where it's serverless. Well, yeah, at the time when I did that, actually, it was only RDS. It was Aurora serverless V1. We didn't have V2 yet. And so V1 was full of problems, and I wouldn't have recommended to anyone in production. But since the release of V2, it was pretty good. So I'll need to. Well, actually, it is. It's a file here. So if someone is interested, download it, open it in Xmind, update it, then push it back to the community. That would be awesome. So yeah, I was saying that Aurora is like 5 times faster than RDS, and it comes with multiple advantages. Like, for example, Aurora provides a read endpoint and a write endpoint. So let's say if I do Aurora here, Amazon Aurora. Let's say this application number 3, you want to do something like a CQRS pattern, or simple terms, you want to separate your read and you want to separate your writes, right? You want to create one endpoint for reading, because this auto-scaling group, all it does, because this application tree, all it does is write. But you want to provide the windows ability to read, and they can also scale differently. And or you have one application that only does writes and the other one that only. So Aurora allows you to do this out of the box. If you're using RDS, you need to use something like proxy. This, yeah, so there's a question what it is. So this is AWS proxy is like it is a proxy. It's a component that you add in front of the database, and it allows you to so let's say, rather than every instance creates its own connection or whatever, you can use the RDS proxy and it will manage, connection pooler. It will manage the connections for you. It's something that I've seen usually Lambda functions struggle with when you have a Lambda function that needs to access some Amazon RDS. And every invocation needs to create a connection to connect to it. There's a different way you can solve this, but also using a proxy would help, definitely. Now, when we're talking about the database, that's when you start talking about read replicas and main replicas. And also here you can have clusters, and the clusters follow usually the same rules as the auto-scaling groups, meaning you need to have a main or master, and then you need all the read replicas, slaves, and then you want them to scale based on load, based on CPU, based on all these other rules. So you want to configure them as well. So let me just call it DB cluster. And you honestly, always use multi-AZ, even if the requirement says that you don't need multi-AZ, always use multi-AZ for your application. RDS is super smart when it needs to switch from one AZ to another, and sometimes it does it without 1 single second downtime. And also, if you want to update your engine, so let's say this is MySQL, 5.7, and you want to update to MySQL 8, you want to start updating one availability zone, route all the traffic to the other one. Then once it's updated, you route all the traffic to it. So you really want to do multiple AZs for database. The advantages that you get versus the price, it's a no-brainer. What else we can add here? Let's see. And then, cache. Oh yeah, we definitely need cache. We definitely want to do caching. Now, when we talk about caching, there are multiple layers. There are multiple ways to cache. There's the cache through, cache. I forgot them. I have an article about that somewhere in LinkedIn. There are multiple versions of caching, but let's keep it simple here. Let's use Elastic Cache. And also here, you want to ask them the question about what type of data that you will be exchanging between the compute, because you want to choose. Usually AWS offers either Memcache or Redis, and they come with their pros and cons. They come with so if I do Amazon Elastic Cache Redis versus Memcache, there's a page here, if I remember, that compare them. One of them, for example, does replications. Redis does it. Memcache doesn't. Snapshots. Redis does it. Memcache doesn't. PubSub. But these are stuff that is built into Redis, like the Lua scripting and PubSub and transactions and stuff like that. And advanced data structures, right? If you are only going to store key value, that's it. You just a bunch of data, put it in memory, access it through a key. Memcache is your guy. It's gonna be more optimized and it's gonna cost you a lot cheaper than Redis. But if you are going to, because you can use Redis for PubSub rather than using SNS, for example. You can use Redis to store hashes. I've read an article about how Instagram encodes everything in hashes and put them in Redis. So Redis is a powerhouse, but it's too big if you only want to do key value store. And Memcache will allow you multi-threaded architecture, which Redis doesn't, right? Yeah, Redis doesn't. So you can scale Memcache and you can have multiple threads. Redis, there are some operations that are atomic in Redis, so they block everything else. The get, for example, I think the get is atomic. Redis get, the get and sets, get sets. Okay, let's not go details, but some operations in Redis are atomic. So if you're doing a scan, for example, and your data is huge, well, every other request that is coming after that, it's waiting. So introduce a lot of latency. Memcache is multi-threaded, so it's easier. So yeah, so just always keep that in mind. I'm just gonna put cache here. And it's just a node, but you might wanna build a cluster. And again, a cluster in Redis is a whole discussion by itself. Maybe we want to put the read here in the cache. It's a whole discussion by itself on how to right size them and then how to build the cluster and how to scale it and nodes and it comes with its own policies also, like eviction policies and TTLs and stuff like that. Some people want to put a TTL. Right, so well, if the interview scenario was asking us to make little to no code changes, would we not want to avoid adding a cache since it requires app changes to use the cache? Yes and no, because I can actually put a cache instance here with CloudFront. And I can have, no, sorry, not with CloudFront, with API Gateway. Yes, I can do it with API Gateway. I can have something like Amazon API Gateway here and put a cache instance next to it. And the way it works is it will use a function under the hood to read and write, just to read from the cache, right? So it will receive a request. The request is going to go back, but before pushing it back, it will cache it. And then you can configure the cache here. So next time you want to read, you can read just from the cache here. So you can bypass this whole thing here. But usually, if you want to use caching, then you have to have some kind of business logic that needs to change. So I would challenge them and I would say, I can't just put a cache somewhere and expect it to work magic. So I need to change some things in the code to make cache work the right way. You can hack it because even the joke, there are two things hard in computer science: naming variables and invalidating cache invalidate. So invalidating cache is a problem. It's a real problem because even if we put the cache here, as we said before, how are you going to invalidate it? How are you going to make sure that when the data changes in the database, well, there's no stale data? Well, you need to build some business logic here, right? Or you need to send the header from the front-end application. There would be a header that says invalidate the cache. Or you need to use a TTL that is super short. But if your TTL is super short and every time there's a call, there's nothing in the cache and you have to go to the database, why use a cache in the first place? So designing cache layer, it's as important as designing a data store layer or a database layer. Of course, because we're talking about optimizing stuff. So yeah, I would challenge that question. Well, I would say yes, we can, but maybe we shouldn't. What else do we have, guys? We have Amazon S3 here. So the Amazon S3, yeah, as I said, I would put one bucket. I wouldn't put multiple buckets. I would really put one bucket. So it's accessed in parallel. Let's move this a little bit down. And let's put the bucket here. All right. And all my, I don't know. Does everything has access? Yeah, so 1, 2, 3, all the applications have access to the same bucket to push data to it. All right. I just want this, move this text. Can't believe they don't allow us. Oh, there you go. I thought they removed it. And so now from the S3 bucket, you said we need to trigger a Lambda function. And then this Lambda function will talk with recognition. So now here it depends on the type of, you can have one Lambda function per media type. One Lambda function for JPEG to process JPEG files, one Lambda function to process PNG files. That's if there is a specific need for it and there is a specific business process for it. But if we are talking about only taking the file, calling recognition, and then storing the information in DynamoDB table, I would say we can use one Lambda function. It's easier to evolve, easier to scale, think about concurrency, all that stuff. But it's going to depend, again, on your business logic. Media processor. I think I have something in my GitHub repo that actually does specifically this media process. And so in the Lambda function, you can build multiple rules for triggers. So let's say you're building the media processor using SAM, AWS SAM. No, I don't want Elastic Cache. The serverless application model. Let's say you're building it with SAM. SAM offers multiple resources. Let's go to developer guide. So there are multiple resources here: monitoring, example, CDK, accelerate, reference. AWS SAM serverless function. Maybe this is going to take us to the right, resource function. So in order to trigger your application, you see here the event source. In event source, you have multiple ways to trigger your application. You can trigger it from an S3 bucket, from an SNS, from Kinesis, from Dynamo, SQS, Cognito, HTTP, whatever. What interests us is S3. So you go to S3, it takes the buckets, the events, and the filter. So when you're building your application, you specify the bucket, and then in the event, you see Amazon S3 supported events. Let's go here. You can either trigger it using when a new object is created, when an object is deleted, restored, replicated, it is tagged, right? So you can build into your function, you can build all these events and configure it on when you want it to be triggered, and you can really be granular. So you can say only trigger it if files end with JPEG are deleted, or if files in this specific folder are added, if a new files has been added there. So you can see the supported events there. Yeah, that's set. And basically the way you write it is something like this. You say events is 3 objects created, and here you filter. So you create a rule and you specify the rule. So this is where you pretty much say, for example, prefix. I want to create an event for either prefix or suffix that ends with PNG, something like that. Let's not waste a lot of time here. Let's go back. And then you have your Lambda function does the processing. Now, a couple of things to keep in mind. When the Lambda function is fetching the file, okay, I see. So is the Lambda function fetching the file and then does process on it? Or is the Lambda function just calls the Amazon Rekognition SDK on the file that is already here? Because those would be 2 paths, 2 scenarios. Every Lambda function, sorry, go ahead.
Yeah, it's storing the information or result after processing in DynamoDB also. Again, the output into S3.
Okay, but is it, okay, I see. So here what I would do is I would to Amazon Rekognition and check the Amazon Rekognition, let's say JavaScript SDK. And I want to see what type of processes can I do. So detect faces. Well, like, am I using it to detect faces, detect text, list faces, recognize celebrity search? Because let's say we're using it to detect faces, or let's say detect labels. I want to see what does the payload contains. Do I need to give it, oh, I hate it when it's like that. Request parameters, that's what I'm looking for. So the parameters, you give it an array, you give it an image. That's what I'm thinking. Like whether you give it the real image as a base64 or just the link. Oh, there you go. So it takes a link to an S3 object. Because otherwise, if you had to give it the image itself rather than just a link, you need to be mindful of the size of the image. Every Lambda function comes with a TMP folder that they increased it recently. Is it 1 gigabyte right now, you guys? I think they increased it. Oh, 512. So because if you had to give it an image, you need to be mindful of the size of the image. But since you can only give a link, so you actually use the Lambda function to call the Amazon Rekognition, detect faces API, for example, or detect labels API, and you just give it a link and then you receive it. Yeah, that's what I was, 10 gigabytes ephemeral storage. That's nice. But also, the bigger the size of the file, the bigger the time it takes to process it, and the slower, and all these kind of things. But before we get there, I wanted to ask you something here. This is something you want to ask also in the interview. Can I put a queue here? Can I have, does this need to be strongly consistent, or can I use a little bit of eventual consistency here? Can I just have the S3 bucket push everything into an SQS queue, and then batch process them, media processor do it in batch. So batch process 10 images per time, every time. So it doesn't, well, it would just be scaling. It would create multiple invocations. But what if I have, like we're talking about hundreds and thousands, and then you need to be mindful of the concurrency, because otherwise my Lambda will consume all the available concurrency for the account, so other Lambda functions will start throttling. So to avoid that, I would put everything into a queue and would configure my Lambda functions to do 1 invocation for 10 messages, for 10 pictures. That way I avoid Lambda functions spinning up, right and left and center and consuming all the concurrency. Exactly. Yeah. Yeah, it would be the queue here. That's so the S3 would take the files, push them into the queue, into SQS queue, and my function would just does one trip. Rather than one invocation per image, it does one trip every 10 images. I put 10 here, but you can put whatever you want. So that's also a trick to consume less for concurrent Lambda executions. Yes, there is a limit, and the limit is per account per region. You can Google that Lambda concurrency limit. So there's 1,000 invocation per AWS region at any given time. Otherwise, you start throttling, and you don't want that. So you want to be mindful of that. So yeah, I want to change a little bit the code in my Lambda function to now call Amazon Recognition using a batch process. And I'm sure Recognition SDK has a batch. If it doesn't, well, I can build it in my Lambda function. Just send an array or maybe do 10 calls or something like that. So, always be mindful of the cost. And also, you receive 1 million free invocation every month. So if you do it this way with like 10 invocation like you batch it, maybe you will never pay for this media processing because you do less than 1 million invocations per month. So that's a way to game the system also. And so this media processor, when it calls, it receives the answer, right? So we need to put a response here, and then it would store the answer in my. All right, Abdelati has a question. What if the detection needs to be ASAP and we don't want to wait necessarily for it? Oh yeah, there you go. So that's why I said, are we comfortable with eventual consistency, or we need strong consistency here? We need to have, latency is super critical. So if latency is critical, then of course we will avoid the queue. And there are other ways also to architect, because this is serverless, right? I can deploy the same solution on 5 accounts and provide those accounts access to the same DynamoDB table. So now I have 5 million free executions throughout 5 accounts, and that's or use Fargate. Yeah, definitely. Or use spot instances if I want to still use a VM. So maybe my media processor needs to use something like FFM MPEG to do, there's a Lambda here, to do processes on the image itself, maybe remove colors, transform it to black and white. And yes, I can install FFmpeg on a Lambda function, but whenever, to process videos and files, but whenever I need to do operations like these, I want to be as close to the hardware as possible. I want to leverage the hardware accelerations. And if I do these processes in a Lambda function, there's the Lambda function is basically, there's an EC2 instance, and within the EC2 instance, there are multiple containers. These containers built using it's Cracker, VM Cracker. No, I forgot the name of the Firecracker. Yeah, Firecracker. And so within the EC2 instances, every Lambda function is a small, tiny virtual machine. And then within the virtual machine, you have the Lambda layers. There's the Lambda API. So there's multiple layers between your code execution, between the hardware. So that's why if I need to do media processing, I would definitely avoid using Lambda function, unless I don't care about the cost, and I don't care if it takes 10 seconds to execute. So yeah, Fargate or something like spot instances would be ideal. Or of course, as Helmer says, just connect your laptop to the cloud, right? Who needs the cloud if I can do everything on a laptop? And here there is a DynamoDB my DynamoDB table. Actually, we got it from here. DynamoDB table. I'm going to put it, I'll put these a little bit down. I'll put it here because it seems that all the instances need to have a read access to the DynamoDB table. Right, so it's just write a response. I would usually build this in multiple layers, multiple pages. So the first diagram, which would be just a high level, and then every one of these layers would build in a different page, but no need for this exercise. And now my applications can read. Just gonna do it this way. Read from the DynamoDB table. Let's put this here. This would be one layer. This would be second layer. Right this way. This writes. Yeah, something like that. What did we forget anything? Oh, let's talk now about public and private and what's public and what's private and what goes into what. So of course we want our instances to be private. All right. Everything here is private. We can't afford our database to be public. Never, 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 never. And, you know, unless there's a real need for it. And if you want to connect to the database from your, oh, my bad. Yes, that is a public. That is a public. Thank you. Thank you. Thank you. Thank you. That's it. The cache, everything here is going to be in its own private layer. We haven't talked about security groups and how to configure them, but I think that would be a lot of details. So for example, your database should not be accessible publicly and should only be accessible from the auto-scaling group that it needs it, and you use the role, you build like an IAM role to allow it to read from it, and then there's no need to deal with access if everything is public. I know, I just put everything public and that's it. There's no problem if you don't have a problem. DynamoDB, there's also a lot to talk here, a lot to unpack. Like you don't need, right? Exactly. You don't need an auto-scaling group if nobody uses your app. DynamoDB, you wanna think about multi-region replication. You wanna add some cache here also in the DynamoDB table, for example. Maybe you wanna add a cache in layer here, so you don't hit always the DynamoDB to read, but DynamoDB also has DAX. DynamoDB DAX, which is Database Accelerator, which again, it uses its own cache. It's a fully managed, highly available cache for Amazon DynamoDB. So it's interesting also. It's a little bit expensive, so you can add your own cache cluster here, or you can just enable DAX. We haven't talked about capturing all the events going through the system, storing them maybe in a data lake, how to build insights from them, how to query them. I think this is going to take a lot more time. So I'm going to stop here. Maybe we do a second session. We will talk more about that. But let's review this. let's review this, and you guys feel free, let me know if there's anything here we want to add, we want to remove, we want to delete. We have multiple customers, multiple, let's say, front-end clients. We host our domain on AWS. So we go in Route 53. This allows us to do more load balancing also at the Amazon Route 53 level. You can do route robin, you can balance using geographic, you can balance using multiple criteria. Behind that, we start filtering our requests. So we do, whitelisting, IPs whitelisting, for example. We introduced DDoS protection here, and we can build more, like, the OWASP top 10 vulnerabilities, for example. Well, WAF has a lot of them configured, built in. And maybe you're building a Laravel application. Well, WAF can protect you from the most common vulnerabilities in your Laravel application, right? So it has a lot of these rules built in, so we can leverage that. After that, we have our first CDN, and with multiple cache behaviors. So you don't need WAF if the bot thinks your app IP is another bot and ignores it. Well, the bot needs to be smart enough to think that, and not all of them. I see where you're going, like build a honeypot. And I used to do that at some point in multiple instances where, for example, when bots tries to connect to an EC2 instance through SSH, usually the default port is port 22. So one thing that we used to do is we used to change the port to SSH to whatever, to port 9512. But the bots will still want to connect using port 22. And so when we capture that connection, we just, in the configuration in SSH, we delay the response by 15 minutes. So they make the first connection and they're pretty much stopped, blocked. They're waiting for the handshake to happen. They're waiting. So we called it SSH jail. They're just waiting there for like 15 minutes, which is good for us. And we received the notification. Yeah, right. we just cost them a lot more time and resources. So, in protection from the security threats, you want to make it more expensive to attack you. That's pretty much it. If you make it easy to attack you, then they will attack you. But you want to make it a little bit harder for them to do it. So we get to an application load balancer. The difference, and of course, every one of these autoscaling group has its own application load balancer, right? When you create an autoscaling group, you get to either attach it to an existing ALB, you get to create an ALB, or you get to choose no ALB, so you want to add it later. But usually, think about it. You need something to distribute the load. After that, well, we have our applications, our instances here have access to the database, there's the cache layer, and then we talked about pushing media to S3, triggering an event using a serverless solution to query Amazon recognition, get the response, store it in the DynamoDB table, and read it. Dude got 6 months of work. Well, I think implementing this, it's still going to be some work. But you know what I love about building it in layers is you can outsource it. You can talk to your DevOps team and tell them, hey, I want to build this specific layer of databases with this configuration, and one person can take care of it. And then the developers team can take care of building this specific or this whole layer, and then a whole different team can build this solution here. Or you can even outsource it to someone external. And then your security team will build this part here. So this is what I like about this layered architectures. They're easy to build, easy to evolve, but you need a lot of work beforehand to figure them out and like find all the requirements and everything. I'm gonna stop here questions, comments? Atul, do you think there's something here that we missed, something else you want us to talk more about?
I think we missed one more Lambda, which was interacting with third party, but we can continue that in next session.
Yeah, here, eh?
Yeah.
Oh, because this is in a layer. Oh, yeah. Interesting. Yeah, let's keep that to a next session. We'll talk about also analytics, data lake, and how to build data warehouses versus data lake versus data mesh and stuff like that. And because when you want to talk to a third party that is external, I recently started using Lambda URL functions, Lambda function URLs. So now every Lambda function exposes a unique URL. So you don't need an API gateway to connect to a Lambda function. And it's really great for those scenarios where you're doing a callback or you're offering a third-party external vendor a way to execute your Lambda function. You create a URL, you give them that, and you can still use aliases. Oh, you can't do canary on it. I think you can't do canary on it. Canary deployments. Anyways, we need to double check that. And yeah, we can touch that. All right. Anything else, you guys? I'm gonna share the link here. So if you wanna check it out, here's the link. Any questions, any comments? If you think about something, I mean, it would be awesome if we can evolve this. All of us, we can take this as a community goal or a community objective to evolve it, create multiple layers, ask questions, and have it as an ongoing exercise and grow it. That would be awesome. Yeah, that's it. Okay, I see. There's some people who are already doing stuff. Who's this guy? Who's this guy? Shul. Oh, okay, I see you. Awesome. Okay, cool. All right. Anything else before? Yeah, it's been like an hour and a half. Anything else you guys wanna say? Otherwise, thank you very much for going with me through the exercise. Thank you, Aplati. Appreciate it. It's always tough when we don't have all the requirements and we have to assume stuff like that. But in interview, they expect you to assume. So always keep that in mind. They expect you to ask questions. They don't give everything. All right. Awesome, Ariane. Thank you very much. Thank you, guys.
Brilliant. Cheers, Elias.
Cheers. All right. Thank you.
See you later.
Bye.